Hello and welcome. This video here is a remake of an earlier posted video, and I decided that I would make another one for this project because I added some items to this project. The previous version of the video did not include some of the features that were later built for this item, so we're remaking the video here. What this item is a mobile transportable D-Star hotspot for ham radio use. This device is designed to provide connectivity with the worldwide D-Star network using commonly available components. And as you can see here, it's built inside of a commonly available military ammunition can, which once held the 50 caliber rounds, right? So we have LED status indication for various processes and items on the side there. On the top, for review, we have the AC on-off power switch, which applies power to the onboard switching DC power supply. We have the 440 megahertz antenna output, which is a chassis mount SMA connector. And to ensure a clean shutdown of the onboard Raspberry Pi computer, we have a momentary push-button switch, which when pressed will send a signal via the GPIO pins on the computer to instruct a command to be invoked to shut the system down cleanly. This, of course, eliminates the potential of any card corruption on board. If we look at the side panel, you'll note here I've added a few things, right? So we have on the side here, we have our AC input, which is a grounded receptacle of a specific type known as a Nutric connector, right? It's a twist lock. We have the USB chassis mount connector, again, provided through Nutric. And then, of course, we have a chassis mount USB connector as well, right? Again, a Nutric style connection. I later added this DC tap, right? Now, this DC tap is two-way. So if I'm out in the field, I can feed DC power into here. Or if I'm operating from an AC power source, I can draw DC power at 12 volts on this. So there's two internal DC buses, 12 volts and 5 volts. So the 12 volts operates the internal transceiver, which is a 5-watt SCADA telemetry transceiver that has direct modulator and discriminator access. These can generally be had on eBay for about $50. This device is intended to be used with either an Ethernet connection, as you see here, or with a cellular modem, right? So in this case, a T-Mobile 4G rocket stick, right? If we take a look at the inside, you'll see all of the components that are used to build this device, right? There's quite a lot of hardware in there. So you can see right here in the extreme lower right-hand corner, we have a USB hub, which is used for 5 volts power distribution. The little white brick in there is a 4G modem, which is directly connected to that outboard USB port. Underneath, we have an Ethernet switch, which you can see there, which carries all the communications. Way down deep in there, you can see the Raspberry Pi with the ribbon cable for the breakout connections, so that way we can attach to the LEDs in the front, right, for status indication. And below the Raspberry Pi, you may or may not be able to see it, is a DV modem, which passes the GMSK frames over the telemetry radio. There's our telemetry radio, a 5-watt programmable radio made by Maxon, typically used for industrial SCADA telemetry purposes. And then underneath the transceiver, you can see in that perforated metal case is a 120-watt switching DC power source, which accepts AC in, either AC at 120 or 240 volts, and provides DC across the DC bus internally. Somewhere way down in there, you can't see it, is a 5-volt regulator, which draws power from the internal 12-volt bus and provides a 5-volt bus for all the 5-volt electronics. the RF cabling for the chassis mount connector up top, and the wiring for the 2 switches right here. So we'll go ahead and get this turned on, do a little demo here. We get this on there. Of course, it's very tight. We'll attach our whip connector. Now you notice this is an SMA, so you can use any SMA whip that is designed to operate from UHF ham bands. Will totally work fine. Or you could use an outboard external antenna, which would also be fine. Right? So once we get that in, it's on, it's good to go. Let's connect our modem. I'll just take the 4G rocket stick there and plug that into the side. Okay. And then at this point, we have our twist lock AC receptacle, which I've custom made using the Nutric twist lock AC power connect system, right? This is done for safety so that the cord can't be easily pulled out if someone trips over it, or if it just gets, gently tugged. In this case, it twist locks into the receptacle and stays firmly connected, right? So as we power this unit on, you're going to see in the front here, the LEDs provide different status, right? So this one on the bottom provides status indication for internet reachability. This one is for the IRC DDB gateway, gateway daemon. This one's for the repeater controller daemon, which provides operational control of the transceiver radio within, right? And then of course this one here shows SD card read-write activity. And then of course we have a simple red flasher up here which shows power activation status, right? So all diagnostic and operational status indications. The way this is programmed, and I've done some special secret sauce scripting that is used to validate the internet connectivity, because one of the things is we don't want the hotspot to turn on and start the daemons if we don't even have internet connectivity, right? So this is designed to operate as a simple self-contained unit that you can set down anywhere, either in a field or in a building somewhere or up high on a hill, and it can operate completely self-contained. So I'm going to go ahead and turn it on, and you're going to see here the LED status has come alive, and in a moment we're going to see the boot cycle, right? So very shortly you're going to see right now the modem is starting to establish contact with the T-Mobile wireless network. Once we have verified connectivity with the internet, the LED on the bottom is going to light, which is our amber internet reachability flag. And then once the system considers the internet reachable, it will start the 2 process daemons responsible for operation. Meanwhile, we're waiting here with our radio, and we'll hear the announcement once the connection to the D-Star network has been made. That will happen once the gateway and repeater daemons fire up. So in just a moment we'll see that. And it's just like magic when it all happens. And any moment now we should see internet connectivity. It does take a couple minutes for the system to boot because there's a lot of processes that are scripted that are occurring. Here we go. Internet is now declared as reachable, and now very shortly the daemons will start. And we'll hear the confirmation announcement from the radio.
Link to REF069 Charlie.
Okay, so we're now connected to reflector 69 Charlie. And if I wanted to, I could connect to any other reflector just by sending a DTMF command. So if I wanted to connect to, let's say, 1 Charlie, I just simply dial it up in my memory, send the DTMF command. and boom, I will get reconnected to a different reflector.
Link to REF001 Charlie.
Okay, so if there was activity on this reflector, we would be hearing it now, but it's very late tonight, so everyone's likely in bed. If I want to shut the system down for easy transport, no problem. Again, remember that shutdown button I talked about? We'll just hold that down for a few seconds until we see a lot of disk I/O. That will be our indicator that the shutdown sequence has been invoked, and it looks like that's happened right about now. And I can let go, and within a few moments, the LEDs will all extinguish, and that will be our cue that the system is finally down for power off. So right now, everything's down. There's a little bit of light showing through, that's okay. A little bit of leakage current on there when the Raspberry Pi goes down, and we can shut the power off, and the system is now ready for dismantling and for transport. This is the K1WIZ Ammo Can Hotspot for connection to the D-Star network anywhere. So you can reach me on Reflector 69 Charlie anytime. Thanks for watching.